4. We've got a two-way switch. So remember how I talked about there being other switches? This is one of them. So a two-way switch looks like this diagram. What that means is when you switch it, it flips to the other line. A normal light switch in a wall is this kind of switch. It has one, well actually, it depends. But for the most part, this would be a reasonable thing to think. So a two-way switch is going to look like this. When you pop the switch, it doesn't go to disconnect it, it pops down to here. So if you pop the switch, it flips to the other one. If you pop the switch again, it flips back to its original. So every time you pop the switch, it flips to the other line. It doesn't go off, it just flips between the two lines. We've got this flip-flop here. All right, so this is an important element in circuits. We want to be able to have other ways to connect things, and this is a really cool switch that's going to let us do some interesting stuff now. So here's the question. Here's the idea that we're going to try to figure out. If we've got two of these, I'm going to hand you two of these switches and an arbitrary amount of wire that you can easily connect. I want you to design a hallway light switch circuit where flipping either one of the switches will turn on the light, but flipping them both will turn the light off. This is just like what we're used to at home, right? They both start down, you flip one of them, and pop, the light turns on. You flip it down, pop, the light turns off. You flip the other one on, pop, the light turns on. You flip this one back down, turns off. But you flip them on, and on, the light goes off. So that means you only have to be at one end of the hall or either end of the hall to be able to turn on the light. This is handy in a hallway, right? Because we don't want to have to walk to one end before we can turn on the light. So, as opposed to most of the stuff we've wound up working through so far, where we've been like, let's figure out how to apply our formulas, let's figure out what the best thing to do is, and then we just, sort of methodically go through it. Designing something like this, engineering problems, a lot of them wind up having math going on for a long time, but at some point, if it's going to be an interesting bit of engineering, it's a riddle. It's a puzzle for us to solve. This is a puzzle. And now I can tell you what the answer is because I know the answer. It's like a riddle. Once you know the answer, you know the answer. But you won't get the chance to experience this riddle if you don't wait for a second and think about it. So I would encourage you, pause this video, take a piece of scratch paper, screw around for 2 or 3 minutes trying to figure out how could you connect this thing. In just a second, I'll give you a hint so you can go think about that hint and try it one more time before I finally give you the answer. So, I'll wait. Okay, so assuming that you took a little bit of a look, or maybe you just skipped up to the answer, oh well. Assuming you took a little bit of a look, but you couldn't figure out, here's the hint. Try it, but try putting the two switches near one another, but don't put them end to end. Put them so that they face opposite directions, and then try thinking about the connection. Remember, you want something where that when you flip one, it's going to cause it to see something opposite. They're going to have to talk to each other because they're going to have to somehow see what the other one's doing in a manner of speaking. So there's going to need to be some information communication going on between their states. So they have to connect to each other in some way. So think about that. Think about trying to turn the way that you're looking at them around. Give it another minute. Give it another shot. It's a really cool idea, and if you manage to pull it off, it's a really great feeling. Solving puzzles is, to me, one of the most satisfying things there is. So, give you another second. Pause me. All right, we're finally ready for the punchline. So, the trick is, like I was saying, we've got the lamp up here and the negative line here. We're going to wind up connecting the negative line directly to the lamp. And there's actually multiple ways to do this, but this is a general idea, and this one is a very good way to wire such a switch. Now, if we've got one of these switches over here, right, and we put another one of these switches over here, so they're facing each other, we can connect this switch like that. And we'll connect this switch to the power source. Now we need some way for them to talk. Say this switch is originally like this. That was a little crooked. Let's make it straight. This switch was originally like this. And this switch is originally like this. Okay. If that's the case, then we can take this and draw straight lines. And at first, they don't talk to each other, right? They don't talk to each other when they're starting off. But if we go back and we flip one of these two, hey, look, we've now completed a circuit. We've got a way for energy to run through. If then we come along and we switch the other end, we've broken the circuit because now it's seeing the other side. So it's a question of, do you guys both see the same thing at the same time? You put them in so they see different things at first, and then they flip between the two states. If their two states are in agreement, power flows. If their two states are not in agreement, power does not flow. So by putting them so that they look at each other in opposite ways, they start off looking at different things, and then you just flip which thing they're looking at, you change the bit of information they have, you're able to have this communication of what the other one is doing. Once they're working in tandem, if they both have the same piece of information, they both say on, it's on. They both say off, it's off. But if it's on off or off on, then we've got offness. So it depends on how we do it. We could also look at it as being on being off and off being off, but it just depends on how we've named it. But the important thing is, if we've got these, it's about this controlling how these states are talking to each other. So it's a really interesting idea, and this bit of circuitry is actually probably in your house or your apartment or wherever you live. It's almost certainly in something you've ever interacted with. Is it some way of being able to just flip it? And so what they have to do is they have to wire to the other one before they wire to the light, if you want to have it in this method. There are other ways to wire this, and that might be one that you figured out. But this is one good way to wire such a switch. All right, hope that made a lot of sense, and we'll have our final lesson on magnetism where we'll get the chance to see what's going on with generators, how it is that we're able to have such a great supply of energy, how it is that a motor can work on electricity, all these cool ideas. All right, see you at Educator.com later. Bye.